discuss the numerical solution for the ordinary differential equations. The numerical solution for the ordinary differential equation we have. So general first order differential equation is of the form. So the differential equation is of the form is y dash of x equal to f of x comma y. This is the initial condition y of x not equal to the y naught. So this is the initial condition is the differential equation. So and so continuously we can ask some questions. We can determine so y of x to y of x1. So y of some value. So that x may be real value. Y of 1.2 and y of 1.3 and so on. Okay, such type of question may ask. So you can determine. So by using the numerical methods, one of the known method is Taylor series method. So how to derive formula for the Taylor series method? How can you define the order of the Taylor series method? So now we are going to discuss that Taylor series method. So see here. So Taylor series expansion of y of x. Taylor series expansion of y of x at the point xn. So now. So Taylor series expansion of y of x about the point x equal to xn as the Taylor series expansion we can define. So like the y of x equal to y of xn plus x minus xn whole to the power of 1 by 1 factorial and power 1 by 1 factorial and y dash of xn plus x minus xn whole to the power of 2 by 2 factor second derivative at xn and so on. So x minus xn whole to the power of p by p factorial by p the derivative at xn and so on. So this is the infinite series which is going to the infinite number of terms. So that equation is represented with the equation 1. Okay, so this is the equation represented with the equation 1. So now if we retain up to pth power of h, we retain up to pth power of h in equation 1. So we get approximating y n plus 1. We get approximating y n plus 1 to y of x n plus 1. Y n plus 1 to y of x n plus 1. So this is the infinite number of terms. We can simply write y n plus 1. Okay, y n plus 1. So y n plus 1 means when you are substituting x, okay, x by x n plus 1. That is if series is infinite series, so that is the y n plus 1 and we y n plus 1 to we approximating y of x n plus 1. So only pth power of h, only pth power of h. So y infinite series is we can expand y of x equal to y of xn plus x minus xn whole to the power of 1 by 1 factor by first derivative at xn and next x minus xn whole to the power of 2 by 2 factor second derivative at xn and so on pth derivative by p factor and so on, okay, which is going to the infinite number of terms. So that means the equation is represented with the equation 1 and if we retain up to pth power of h, so this series can be written up to pth power of h. So how can you substitute the pth power of h? So we can replace. So we know so each and every nodal point is equispaced nodal point. That equispaced nodal points can be written as suppose x n plus 1. X n plus 1 equal to the, so h is the increment. So x n plus h is the x n plus 1. We can denote simply. So the x n plus 1 minus x n equal to the h. Okay, x n plus 1 minus x n equal to the h. So just we have to substitute x by x n plus 1 in the given equation. So x by x n plus 1 in the given equation. So that equation can be transformed as y n plus 1 which is equal to y of x n plus h y dash of x n plus h power 2 by 2 factorial into y second derivative at xn and so on, which is going to the infinite number of terms. So which is going to the infinite number of terms. It has infinite number of series. The series is the infinite series. So the series is infinite series. So now we get approximating y n plus 1 to y of x n plus 1. Y n plus 1 to y of x n plus 1. So that is a pth power of h. H power is p. So we can write this equation to h power p is y of x n plus 1 which is equal to, so y of x n plus h power 1 by 1 factorial into h power 1 by 1 factorial into, so y dash of x n h power 2 by 2 factorial into y second derivative into x n and so on. So h power p by p factorial into y pth derivative at x n. Okay, so this is the h power p term. Okay, series. So up to h power p. So this series expansion up to h power p. Okay, so this series, so this method is called the Taylor series method. This method is called the Taylor series method of order is P. Search for P is indicate the order is P. Okay. Taylor series method of order is P is, you can simply note the equation